Welcome to a new episode of Goodbye Greenwashing. Goodbye Greenwashing is a video series we started a few years ago to discuss new sustainability-related product claims, why a new claim is arising, and how we can make that claim in a reputable way without greenwashing. So in this episode, we are going to be tackling a topic that's building prominence in the industry, which is biodegradability. Perhaps you've seen the claim biodegradable on packaging or personal care products, maybe even in the clothing sector. We're seeing this claim come up in a lot of different consumer spheres, emerging as a prominent sustainability-related claim. But the science behind biodegradability is complicated, so it's really important to be equipped with all the information about this to determine if it's the right claim for your products and how to make a biodegradable claim without greenwashing. This video series started in response to the myriad of non-performance-related product claims that were cropping up in our industry and other consumer goods sectors. From the natural movement to the paraben-free movement, clean beauty, cruelty-free. At first glance, all these shifts in the market seem kind of haphazard. But what's really happening is that the definition of what makes a good product is getting broader and broader. Good used to be defined by performance alone. Then a focus on safety came into view, then animal welfare, and now products with a low environmental footprint represent this quality of goodness. Consumers are really tuned into sustainability and environmental responsibility. That should come as no surprise. Within sustainability, the qualities and claims consumers are looking for are getting more and more sophisticated too. So similarly, the way the definition of good has expanded and created more claims, the definition and associated claims of an eco-friendly or an environmentally non-harmful product has also broadened out. I think the first look at this was about packaging. Excessive packaging, non-recyclable packaging starts to raise red flags to consumers that maybe this isn't the best product. Beyond packaging, ingredients come into question. Where are they coming from? Are they natural or petrochemical derived? At the core of it, when assessing environmental impact, you have to look at the entire life cycle of the product to evaluate overall sustainability. Innolex, as you know, is an ingredient designer, so we are going to look at the life cycle of an ingredient. We evaluate an ingredient's life cycle through 6 key stages. Starting with feedstock selection, the considerations in this stage include material origin. Is the product derived from plants, animals, petrochemical, and how are those feedstocks sourced? Next is ingredient manufacture, which of course includes the energy use, water use, efficiency of producing the material. Here is where we see many of the principles of green chemistry bear their fruit in terms of sustainability benefits. Then we have ingredient transportation, covering the impact of the packaging, the distance and transportation type of getting the ingredients all over the world where they can be produced into finished goods. Next is product manufacture, which refers to the impacts of taking those ingredients and blending the finished good. In the consumer use phase, we're covering, of course, the health, safety, and performance of the product. But in terms of environmental impact, this could also include the impact of the water heated for the consumer to use the product and whether it's a leave-on or rinse-off product. And lastly, there's the end of life, whether the product rinses down the drain or unfortunately goes unused and is sent to landfill, or whether it wears off a beachgoer into the ocean. All of these situations result in various levels of environmental impact. So end of life brings us to the topic of today, biodegradation. What is biodegradation? Biodegradability is all about how substances break down naturally over time. There are 2 main ways things can degrade. First is abiotic degradation. This happens through physical processes like oxidation or phytolysis, where substances are physically broken down. Biotic degradation, or biodegradation, occurs in the presence of tiny living organisms called microbes. These microbes help break down organic substances. Within biotic degradation, there are two types. Aerobic biodegradation happens when there's oxygen present. It's the most common form of biodegradation in natural environments. The second form is anaerobic biodegradation, which happens when there's no oxygen. It's less common but can occur in certain situations like some steps of sewage treatment. The other important factor of biodegradation that's important to consider is the completeness in which it breaks down. Complete biodegradation is achieved when the substance is not only broken down into simpler forms of the original material, but it's broken all the way down into carbon dioxide, water, and biomass, which are all non-harmful to local environments. Biodegradability is an important factor in understanding how substances impact the environment after use. When something is easily biodegradable, it can break down naturally, reducing its harm to the environment. Now, why does a material's ability to biodegrade indicate its impact? Well, when referring to a chemical, a molecule, let's say a cosmetic ingredient, if the material does not biodegrade and it's introduced into the environment, it's more likely it's going to persist. And if it persists in that environment, then there's an opportunity it's remaining unchanged, which yields the opportunity for it to accumulate. So if the substance accumulates, then there's a potential that it will be toxic. As we all know, or maybe as a reminder, toxicity is a function of concentration. So the more we have persistent accumulating substances increasing in concentration, the potential for toxicity to the environment, ecosystems, and the organisms that live within it also increases. Choosing biodegradable ingredients is really important to avoid that potential toxicity. There are many ingredient categories in our industry that are either not biodegradable and can be made biodegradable, or there are already biodegradable alternatives to those materials. Let's look at an example in order to dive into the science behind biodegradability and also the market approach of how to address the consideration of biodegradation now that we know how important it is. Silicones are a category of chemistry derived primarily from minerals that make up a variety of functional and sensorial ingredients within the beauty and personal care sector. The silicone molecule is inorganic, so if we remember our categories of degradation, the subcategory that's relevant is abiotic degradation, or the breakdown through physical processes. Silicones will degrade in response to physical processes, but it takes a very long time to do so. So in the process of slowly degrading, there is still the potential of persistent accumulating silicones in the environment. What we want instead is a material that can break down quickly and ideally can break down through microbial action, since microbes are present in water treatment, as well as in natural environmental conditions. But we can't just take an organic substance or any alternative molecule to silicone and assume it's going to degrade faster just because it's theoretically able to biodegrade. That would lead us to a potential greenwashed claim. Instead, we need to run some experiments. The most widely used and globally recognized tests for biodegradability are from OECD, the Organization for Economic Cooperation and Development. These series of tests are made to model or identify inherent properties of the chemical by seeing how it responds to different conditions. The testing is very nuanced, and if you want to learn more specifics, all of the details can be found on the OECD website. But here I'm going to cover a general example process of testing using one of our ester technologies. At a high level, the OECD biodegradability test methods present conditions in which to evaluate our substance, both by speed and completeness of breaking down. Based on speed and completeness, the level of biodegradability can be determined. Now, there is much interpretation for the standards. Hence, we partner with an expert lab to conduct these tests and present their conclusions according to the methodology. So the testing is evaluating completeness and speed of breakdown. Completeness indicates what types of substance it's breaking down into, if it's carbon dioxide, biomass, and water, or if it's only partially breaking down. And speed is evaluated because that will indicate if it has the potential to persist and then accumulate. So first, we evaluate a molecule by OECD Test 301. This test has very stringent conditions, making it very difficult to biodegrade. So if the substance does biodegrade both completely and quickly, then it could be classified as readily biodegradable. If it doesn't meet the criteria for readily biodegradable, in theory, you can evaluate it by test 302 next. But in practice, your expert lab is likely to interpret the results of 301B to give you some indication of its level of biodegradability, even if it's not classified as readily. This is why, in practice, we have a variety of classifications internally. It's a practical approach rather than a theoretical interpretation of the standards classifications. So by testing the ester diheptylsuccinate by OECD 301B, we determined its classification readily biodegradable. But to make the product Lexfeel N350, the silicone alternative, the ester is actually combined with a copolymer. So we must test the copolymer as well. Caprylyl glycerin sebacic acid copolymer also passed OECD 301B conditions with a readily biodegradable status. With these components together, classified as readily biodegradable, we can also classify Lexfeel N350 MB as a readily biodegradable ingredient. It's very important to know that the OECD test methods are not designed for cosmetic formulas. Biodegradability is an inherent property of a molecule. If you have a formula with 50 molecules, it would be very difficult to identify the properties of each molecule. So it's best to test in individual molecule form or in simple mixtures. In other words, test your ingredients rather than your formula. Once you have this classification or status, you have a responsibility to communicate that status in a way that's digestible to our audience, which is ultimately end consumers. Since finished goods are a formulation or a mixture of individual chemical substances, we must know the biodegradation status of the ingredients. The recommended way to make a biodegradable claim is to source only verified biodegradable ingredients and include descriptions of what component level you evaluated and how you evaluated biodegradability. Here's a great example from Unilever making a claim of a biodegradable formula on a conditioner. The label reads, 100% of our ingredients break down into basic components shortly after use or are already in a form that can be readily returned to nature. Ingredient biodegradation status is based on OECD test methods 301, 302, 310, and principles. It is key that we employ these science-based methods to making a biodegradation claim, not only to preserve the truth of making claims related to environmental impact, but also because this space is riddled with opportunities that can lead us to a place of greenwashing. So greenwashing is the practice of marketing a sustainability or environmental benefit without actually backing the claim up or making a true positive impact. Let's walk through the 7 sins of greenwashing so we can identify the risks and potential pitfalls when it comes to making this claim. First is the sin of the hidden trade-off. This is a big one for biodegradability because, as with any sustainability claim, it's really just one element of that whole product's life cycle. So biodegradation indicates the impact at end of life, but really the whole life cycle should be considered. In other words, you don't want to be making only a biodegradable claim when the feedstock selection, the ingredient manufacturer, the product manufacturer, and other life cycle stages have not been considered in your sustainability strategy for the product. The next is the sin of no proof. It's very important that we don't just start throwing out this claim without proof, which can lead to misrepresentation and misinformation. We need to be willing to evaluate biodegradability through scientific tests. The third sin is that of vagueness. So with your claim, be specific about how you came to the conclusion. Reference the specific tests and principles employed. Fourth is the sin of worshiping false labels. Currently, I have not seen any certification model or scams about biodegradability verification, so hopefully we're not at risk for this one. But it's important that if you're making your own claim, that you explain how you uphold that standard. And anytime you're partnering with a third-party label or certification model, it's important that you evaluate their credibility. Next is the sin of irrelevance, which is also key to avoid here. Remember, biodegradability is only relevant to organic compounds or carbon-based substances. So if you're talking about inorganic compounds, such as a mineral-based ingredient, you're referring to degradation. Don't make a biodegradable claim on something that's not possible to biodegrade. Next, there's the sin of lesser of two evils. So this is also tricky when it comes to any sustainability claim. It begs questions such as, is a readily biodegradable but synthetically derived material better than a naturally derived but ultimately biodegradable one? It probably cannot be determined in a holistic sense what the lesser of two evils is here without conducting a life cycle analysis or an environmental impact assessment. However, it's important to keep in mind the whole life cycle and not just cherry-pick claims that apply to your product. And last is the sin of fibbing. This one's pretty obvious. Don't outright lie about any sustainability claim or biodegradability claim. If we avoid all the 7 sins of greenwashing by running specific tests, seeking the required proof it takes to make a specific, honest, science-based claim, we can help consumers choose the ingredients and formulas that are biodegradable and have a reduced impact on the environment and local ecosystems. So to wrap up, let's review what we've learned about biodegradation. First, it's a key indicator of a non-harmful impact on environment and ecosystems. If something biodegrades, especially if it's quick, you can be assured that it won't present toxicity to these ecosystems or water systems. And secondly, it's easy to accidentally greenwash when making a biodegradable claim. So leverage biodegradable ingredients and reputable studies to verify your claims. Choose biodegradable, build sustainable formulations, improve environmental impact. That's all for this episode of Goodbye Greenwashing. From all of us at Innolex, thanks for watching and learning along with us as we explore making sustainability claims rooted in science and credibility.